Hello, my name is André. I'm here to present STN PLAD, which is a dataset for multi-site power line assets detection in high-resolution UAV images. This was a project done in cooperation between Universidade Federal de Pernambuco, Centro de Informática, Voxar Labs, Informa, and STN. Firstly, for some context, defective components today are the main problems that power line and power line companies in general face. So they can lead to a lot of problems such as power cuts and transmission tower falling. So this can lead also to high financial costs with fines and lawsuits. So it's very important to keep the inspection process up to date. With that in mind, you can see in the video that this inspection process can be very dangerous and risky for the workers. So automating the inspection process is a natural way to go in the future. However, many of the techniques today depend mostly on data, and public data is very scarce on power line assets. So this work goes in this direction to try to propose a new data set with real-world power line images for help the scientific community coming up with new methods and techniques in that sense. So a few numbers to exemplify here. On average, a power cut on the US of 30 minutes can lead to a $15,000 loss, and a 8-hour power cut also in the US can lead to a $90,000 loss. In Brazil, fines can reach millions of reais for only a few days of power supply interruption. In order to exemplify how unsafe and insecure the inspection process can be, an Iranian power supply company between the years of 2006 and 2012 got more than 100 workers injured. So we went on field with a team of people composed by inspectors and drone pilots to capture power line images via UAVs to help constructing and building these new data sets to automatically detect assets in images. So with that, we can reduce costs and safety risks on the inspection process. Also, it's very noteworthy that there are very few public data sets today regarding to power line data sets and power line assets. As we can see here in the picture on the left is the team that conducted the data collection protocol, and we're composed of inspectors, drone pilots, and we used the drone to capture images from real-world power lines. Today, besides our data sets, there are only two other public power line assets data sets, which are the one in the left and the one in the middle. They only have one type of asset, which is insulator, and they're not inserted necessarily in real power line background, as you can see. On the other hand, our data set, STN PLAD, as you can see in the image on the right, has images from real-life power line backgrounds with multiple assets in each of the images. Here are some information to compare between those data sets. As you can see, the number of assets is much bigger in ours. Density of objects per image is also much higher. And the background variation, such as illumination, angulation, zooming, Like the distance between the camera and the object is very diverse. So there are some sample photos here from our data set. These are very high resolution images, greater than 4K resolution. As you can see, there's much information in each of those images regarding many power line assets in each of them. Those images were annotated following 5 different classes of assets. They were towers, insulators, spacers, ID plates, and dampers. As you can notice, there are many differences between those objects. Many of those objects have very different sizes. For example, towers are much bigger in those images compared to stock bridge dampers. So these are some more properties of the data set. These are class names, labels, number of instances per classes, a number of instances per image on average, and on average the size of each object on each image in pixels. For the evaluation methods, we used 2 very recommended by the literature methods for this application domain specifically, which were the SSD method and the faster RCNN method. These 2 object detectors were very recommended by the works that deal with power line assets detection. So we used them to evaluate our data set. And we discovered in our evaluation that they have plenty of room for improvement. So we proposed a pipeline to improve the performance of those object detectors. Here you can present the workflow of this pipeline, which we call MS-PAD, in which the input image, which has a very high resolution, is go in 2 different paths. One is resized into a smaller image and fed into the neural network, and the second path, the image is cut into a grid of smaller images and also fed to the neural network. The first path is used to deal with large objects such as towers, insulators, and the other path is fitted to deal with smaller objects such as stock bridge dampers. As for the results, we noticed that the SSD had the better performance between SSD and faster CNN, so we used SSD as a temporary baseline in our experimentations, and it achieved a 75.5% mean average precision. So it's the mean of all the average precision classes. And when we compare to our pipeline using the MS-PAD, the MS-PAD were able to improve greatly the mean average precision from 75.5% to 89.2%. So this was greatly due to the stock bridge damper improvement, which in the MS-PAD pipeline it was dealt with. This is our some qualitative results regarding the bounding blocks of the detected objects. In the image on the left, you can see in white a transmission tower being detected, in blue insulator chains, in yellow spacers, and in red here a small ID plate. And in the gridded images, we can see that the MS-PAD also performed very well in detecting dampers. For the strengths and limitations of the developed data set, the main strengths are that this is the first public power line data set with more than one asset. We have 5 different types of power line assets. This also was retrieved from a real power line context and real power line scenario, a functional power line, and in varying conditions such as varying background, illumination, zoom, assets angulation, and others. We have a high density of objects per image, and that's a good thing since we have very high resolution images. And our final baseline, which was 89.2% MAP, left plenty of room for improvement. As for the limitation, there are not many images, since there are only 133 images. However, those images have very high resolution to overcome that problem. And the other limitation is that the images are from only one power line company. Finally, the STN PLAD is a new public, real-world, high-resolution, multi-asset power line dataset. We notice in our research that there is a lack of public data of power line assets images. So we produce this dataset with UAV images, annotated many objects, more than 2,409 objects, divided into 5 classes, and we are making it public, so anyone can download the dataset as of today from the GitHub and start applying and developing new techniques to it. We also propose the MS pipeline to improve the object detection performance of general purpose object detectors such as SSD and faster STN, and we are able to achieve an 89.2% MAP. So this is the baseline to be beaten. So finally, you can download the dataset, STN PLAD dataset, from this GitHub repository here. And if you have any questions, you may contact me on this email. So thank you very much.